Hello, good morning friends. I hope you are following the thermodynamic video lectures. In the last class what we discussed means we derived we drawn the graphs between the PV and VT and TP. Now this lecture goal is to derive the what is the work done in a adiabatic process. So let's assume we are performing an adiabatic process with the help of the system is the ideal gas. The system is an ideal gas. So the system is converting from initial state to Vi2. The system is moving from another state to Vf. We are using an ideal gas. Now our goal is to find out what is the total work done in this step from initial state to final state. What is the work done? So we have the formula for the work done is equal to integral of dW, that is equal to integral of PdV. This is the formula we are having, PdV. Now in our case the work done is equal to integral of initial case of volume Vi, final case of volume Vf into PdV. But here is the in our process the adiabatic process P and V, the P is not a constant term. Then we are unable to take this P to outside because of it is not a constant. So in the adiabatic process, what is the P and V relations? We have the P and V relation is equal to PV power gamma is equal to some constant. So depending upon textbook, the constant values are taking different value. So here I am taking the constant is equal to small k. So and then PV power gamma is equal to some k, small k is there, then P is equal to some constant k divided by V power gamma. Then P value can be substituted in this equation. This equation is 1. The value of the P can be substituted in this equation. Then work done can be written as work done W is equal to integral of initial volume Vi to final volume Vf2 small k divided by V power gamma into dV. This is the formula we are having. Now k is the constant, then k is the constant means we can take it out from the integration procedure, then k into integral of V initial to V final into here V power gamma is there. Now I am sending this V power gamma to denominator to numerator, then V power minus gamma into dV will come. I hope you know the formula integral of x power n into dx is equal to x power n plus 1 divided by n plus 1 we will get. Here instead of n we are getting here we have the instead of n we are having negative of gamma we are having instead of just to substitute in this equation. This is the formula. Then the continuation procedure is equal to integral of k into V power minus gamma plus 1 divided by minus gamma plus 1. This is the value we are having. Now the limits must be applied. Upper lower limit is equal to Vi, upper limit is equal to Vf. Now substituting the limits in this equation, then small k into flower bracket open, that is equal to 1 minus gamma I am taking, 1 minus gamma I am taking. So bracket open, upper limit I am substituting Vf 1 minus gamma minus Vi 1 minus gamma. This is the value we are having. Now once again I am recalling gamma is equal to Cp by Cv. This value is always greater than 1. Now will you please look on this part. In this part 1 minus greater than 1 is there. This value will be get the negative value. So to eliminate the negative value in this equation, I am interchanging this value by taking the negative term here, and also I am interchanging this term to take the negative term here. That is equal to k into I take a negative term here gamma minus 1. Again I am taking negative term here. So that is equal to by interchanging the terms here Vi into 1 minus gamma minus Vf 1 minus gamma, flower bracket close. Now will you please look on this negative term is multiplied and it will form the positive term. then gamma minus 1 I am taking out, then k power small k into gamma minus 1 bracket open, that is equal to V initial 1 minus gamma minus V final 1 minus gamma. Again I am checking in this equation, gamma is the positive term and it is also greater than 1. So here the 1 minus gamma is there, this term will provide the negative term, this term is the negative term. So to eliminate the negative in this equation, I am sending this term as a denominator, to it will become a positive term. So then what is the formula we are having? Once again I am writing k power gamma minus 1 into V I 1 minus gamma minus Vf 1 minus Vf. Once again I am writing Vf, let me check once again, Vi 1 minus gamma, Vf 1 minus gamma is there. Let me write Vi 1 minus gamma, Vf 1 minus gamma is there here. So here I am our goal is to eliminate the negative term in the equation. So I am sending this equation. So I am demodifying this equation like this, 1 divided by Vi gamma minus 1. If it is the denominator, we can write like this, divided by Vf gamma minus 1. Then there is no any negative term in this equation. Here is the positive term, here is the positive term, here is the positive term. Now I am sending this gamma inside this equation. What will get? Please look on this one. So once again I am recalling our adiabatic process equation. PV power gamma is equal to some constant. That constant we assume that small k. That means P initial V initial power gamma is equal to some constant or P final or V final power gamma is equal to some constant, that same constant. So now I am sending k this side, that will what will happen, 1 by gamma minus 1 in bracket, k is sending here, k divided by V small Vi gamma minus 1 minus k divided by V final gamma minus 1. Here initial terms are there, initial terms k value I am substituting in this place, and final terms are there, I am substituting final terms in this equation. Now this formula can be written as gamma minus 1 or bracket open, substituting the initial terms here, that is equal to P initial V initial gamma divided by V initial gamma minus 1, V initial gamma minus 1 minus P final V final gamma divided by, just I substituted final value because of the denominator term is available, V final into gamma minus 1 or bracket close. Now again I am looking here, this term is nothing but just I am modifying this term as please look on this one, I am decreasing one step here, Vi power gamma into V power minus 1 we will get. This power minus gamma, this power Vi power gamma is cancelled. In the similar manner here also Vf power gamma into Vf power minus 1 will get. This Vf power gamma and Vf power gamma is both are cancelled. This is the Vi. Vi is in the denominator term. Denominator term Vi is the my negative term. If you send the numerator term, so then it will become a positive Vi. Then this formula can be written as, that is equal to 1 by gamma minus 1 into bracket open Pi Vi. So Pi Vi minus Pf Vf we are getting. From the ideal gas equation we already known PV is equal to nRT formula is there, that is equal to Pi Vi is equal to nRTi we will get. So that is equal to Pf Vf is equal to nRTf we will get. So instead of here, this is the one formula, this is the formula for the work done. One more formula we can take by using of ideal gas equation, then work done W is equal to 1 by gamma minus 1 plus bracket we can P1 Pi Vi is equal to, can be written as a nRTi minus nRTf. nR is the common term, we can take it out that one, that is equal to nR divided by gamma minus 1, that is equal to Ti minus Tf or bracket close. So then we can write it that this is the work done for the work done in the adiabatic process in terms of temperature. So then this formula can be written as here nr divided by gamma minus 1 into small delta t. This is also another form of the work done in adiabatic process with respect to the temperature. I hope you understand the lecture. Thank you for watching. Thank you.